Good afternoon. Good afternoon, all. First of all, sorry for not being able to conduct yesterday's session. So we have already discussed experiment number 1 and 2 of our CPPL lab. Today we are going to discuss about what is the content of experiment number 3. Experiment number 3 is based on Haskell programming environment. You know already that Haskell is a functional programming language, and we are going to have a tutorial on that. So this is a hands-on tutorial for which you require access to the lab machine, that is 139.5.28.138. You know your user IDs and passwords which are already shared with you. So we will first look at what exactly we are supposed to do in this tutorial, and then we will look at how to go about completing this particular tutorials write up as well as performing the tutorial. Okay, the lab objective that this particular experiment targets is design and implement declarative programs in functional and logic programming languages. The lab outcome that is mapped is after doing this lab performance, student should be able to design and develop solution on declarative programming paradigm using functional as well as logic programming. Okay, so for this experiment we require a text editor and as well as we require Glasgow Haskell compiler. Okay, Glasgow Haskell compiler. Any version of Glasgow Haskell compiler 8.0 plus will do for the experiment. The theory part which you need to write in your write-up. So in the write-up you will write experiment number 3, the aim of the experiment, and then you will directly write the theory part. Theory part includes what is the meaning of functional programming language. Okay, then it tells you the limitations of functional programming language as well as the advantages of it. It then tells you about what is Haskell and what are the important characteristics of or features of the Haskell programming language. Okay, once this is done, we need to start writing. We need to actually start performing the steps of the experiment. So far in the write-up we have written. I'll just repeat so that you know what should go in the write-up. By the way, this is a manual and this is not a write-up. In the write-up, you will be writing experiment number 3. Then there will be aim as it is. Then you will write theory as it is. And once that is done, the next thing that you are supposed to write, I will let you know afterwards. Okay, so far this much you need to write in your write-up. Now we'll see what exactly is the part of the tutorial. The part of the tutorial requires you to perform these 4 steps. They are not simply one step at a time. Okay, there are 4 different things that you need to perform in this tutorial. First thing is you should be able to download and install Haskell compiler, which will provide you a platform using which you can execute a Haskell code. Second step is to perform basic arithmetic operations. Third step involves to perform basic logical operations, and fourth step involves performing basic comparison operation. All these operations are on the Haskell platform, and the software that we are going to use is referred to as GHCI or Glasgow Haskell interface. Okay, this GHCI we have already had an experience of using it. It's a interactive environment which involves you to write Haskell statements as command and execute them one by at a time. Okay, so it's like a shell wherein you can type in Haskell statements and those statements you can execute and see the output right away. So it's not exactly a compiler, the GHCI, it's an interactive shell or an interactive programming environment meant for execution of Haskell code. This particular write-up includes all the details that you need to perform in order to download and install Haskell compiler on Windows. Okay, so we need to visit this particular website, which is www.haskell.org. Click on the prior release place. So I'll just show you simultaneously. So I need to visit to www.haskell.org. Okay. Then once the website opens, I need to go to prior release. So there's a download section. Okay, sorry, there is a download section. I need to click that, and there will be prior release somewhere on for Windows. So that I need to go about. So I'll just show you in the write-up. That's easy to go. So it is haskell.org/platform. The link is, so the diagram is a bit distorted. So just to make you aware which particular page you need to go on this website, it is platform. Okay, sorry, platform, I guess. Yeah, platform. Okay, once you get this particular link, so this link is https www.haskell.org/platform. I'll just copy this and paste this over here. Sorry, I just need to open a text box. Need to put this link here. Just increase the font so that it is visible to you. So this is the website that you should open. Okay, this is the website. I hope this is readable. And now what you need to do afterwards is you need to click on prior releases. So here, this is prior release. So these are the prior releases. You need to select the appropriate version, whether it is 64-bit or 32-bit, depending on your operating system, and that you need to download. So now the next step is you need to download 8.6.5. So this particular step involves installation of Haskell version 8.6.5. There are various versions of Haskell available over here. 8.6.5 is the version. So this is the version. This was released in April 2019, and this is the setup for Windows 64-bit. So I need to click on this. This will download an exe file, which is a setup file for x86 64 architecture machine, which will install Haskell on your machine. Okay, I won't be able to show you rest of the steps because I already have Haskell on my machine, and my machine is a Linux machine on which I'm showing you or demonstrating you. Okay, so please remember that other steps you just need to follow as they are in the given write-up. So the download folder, you will find the setup, which is an exe file. The name will tell you that it's an exe file for requisite Haskell platform. Double click on that particular file and run it as an administrator. Okay, once you run through the setup, it will install Haskell, and you need to change the bin path. So you need to figure out bin path for the Haskell. So generally, if you keep everything as a default installation, your Haskell will get installed over here in this particular directory. Inside this directory Haskell platform, you will find a bin directory, bin, which is binary directory. So you need to copy that path. So here, if you see, this is the PC on C drive on the program files, Haskell platform under the version number 8.6.5, there is a bin directory. So this path you need to remember, that is you need to copy, and you need to set it as an environment variable. Setting of environment variable makes it easy for you to next time whenever you are executing Haskell command, your operating system knows where exactly is the Haskell compiler stored on your machine. So this is what you need to perform as step number 5. Now you will just see how to change the environment variable in next step. Okay, so you need to go to advanced system settings, open the system properties tab, select the environment variables, and the environment variable value you need to put is the bin path. Okay, so you need to set your environment variable as such. If you have a different location where you have installed Haskell platform, you need to accordingly alter this path of the bin directory. Okay, so as you see on this machine itself, the bin directory is under 8.6.5 and not directly under Haskell platform. So this should actually be slash 8.5.6, and then there should be one more slash and then bin. Okay, so your path must be adjusted properly. If your path is adjusted properly, you will be able to run the Haskell commands. Now, once the installation is over and path setting is over, next thing you need to do is you need to check the compiler from the command prompt. So you need to open the command prompt, that is command.exe, cmd.exe, and at that prompt you need to type ghci on Windows. Okay, as you type ghci, it will open up interactive Glasgow Haskell compiler session, which will have at its prompt a prompt which reads prelude. So the prompt that you see, so this is actually H. The prompt that you see after running ghci, okay, the prompt prompt is the string that I see at the start of the command line, which is going to be prelude. Okay, and this will be the prompt. If ghci runs properly, prompt you see when ghci runs. So if ghci runs properly, you will see this particular prompt. The prompt reads P capital prelude. So this prelude is the standard library of Haskell Glasgow compiler, and it is by default loaded into your system. If you load a different Haskell program, then this prompt would change with the name of that Haskell program's main function. So whatever is the main function in that program, that name would appear over here. Okay, so that's about how to install the GHCI environment. Now this is the half part, or this is, I guess, as we see, first part of our performance of the experiment. Now, if you do have PCs at home which have Windows operating system, you can follow these steps in order to install GHCI and understand how this works. If you do not have PC at home, you are not supposed to follow these steps up to in the part 1. Okay, please understand clearly. If you have PC or laptop at home, and if you have GHCI, so if you have, you can download and install GHCI, you can do so and understand it for Windows operating system. It's not a compulsory thing. But part 2, part 3 and part 4, there are commands which are related to basic arithmetic commands, then basic logical operations, and then basic comparison operations. These you need to perform on the GHCI environment. So we must start a GHCI environment. Now up to this point, I told you how to install GHCI. If you do not have GHCI with you, you can do a simple thing that you can log into the remote system, the remote lab system. We have already seen how to do that, okay, in our Monday session. We have seen. So I'm assuming that you have reached up to that point. So what you need to do is you need to have a terminal based access, either using putty or maybe using the software that is there on the mobile, which is called as TRMUX. So either you can use putty from Windows, just written Windows PUTTY software, or TRMUX software. You can log into the remote machine, which is 139 5.28 sorry 28.5 5.138. I just checked the IP address. As you know, I always crumble with that IP address, 139.5.28.138. I just copy paste this IP address so that it is evident to you which IP address you are supposed to log in into. So you know your login ID, it's equivalent to your roll number. So your roll number RNO10 would be login ID for student with roll number 10. Okay, so that must be clear to you. So this is the way you can access the machine. So this is the user ID. This is the IP address to which you are going to log in to. Okay, fine. Once you logged into this particular machine, you will get this particular interface. Here, instead of KGC, you will look at, say your roll number is 10, it will be RNO10 @ same host name will be there will be a tilde over here, and there will be a dollar. Okay, I hope this is visible. I'll just increase the font. I'm not sure how much it is visible. Fine. Okay, now when you start GHCI, to start GHCI, you need to type in GHCI. If you have installed GHCI in part 1 on your Windows machine, just start command.exe, that is cmd.exe, and type in GHCI and it will execute. Okay, so this is the prelude prompt that I was referring to. Now, as part 2 of the experiment, what we are supposed to do is we are supposed to, sorry, I just need to close this up. Where is the document? Oh, yeah, I lost the document somewhere. So this is the document and this is my prompt. Okay, where is the document again? This is the document, this is the prompt. Fine. So we need to just perform the steps or basic arithmetic operations. We have done this, but just for the sake of completion, make sure you're able to do this. So if I type in a command 2 plus 3, it just operates a plus operation on 2 and 3 and we get 5 as an output. So every time you do perform these on your Haskell prompt, you are just supposed to note the output. So this is the working part of the experiment. So you are supposed to write a command and its output. Make a list like that, make a 2-column list like that. This is the command, this is the output for the arithmetic operations. So how many operations are there? I guess 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 operations are there. I'll just quickly run through those operations. So it is 2 into 3, then 2 into bracket minus 3, run them as they are written in the write-up writing instructions. Note the output and go ahead. That's what you are supposed to do. So 2 minus 3, then 2 divided by 3. It's a division and it is a floating point value that you receive as an output. Then I have 2 raised to 3. Okay, that gives you output 8. And if I type in it is a variable that actually stores the result of previous run operation. So if I type in it now, it showed me 8 because 8 was the result of the previous operation. If it would have been, say, I had done 2 by 3 and then I had written it will give me that particular output. So it is a what you can say, a variable that if I access, I just know what was the previously executed operation on GHCI. Okay, the next thing now, we'll just copy this particular thing. I don't want to write it. This you can also do on your machines. Right click and paste. And this is 15 to 100 minus 4999. So this tells you that operators have some sort of a preference order of execution. So 15 to 100 will happen first and then 4999 will get reduced. So 5000 minus 1, so minus 4999 gives you minus 1. If I want to actually prioritize some operations first, then that I can do using brackets as usual in any programming language, and that is what is evident here. Evident here. So I first do 100 minus 4999, which is a negative number, into 50. This much is the result. So that's what is done over here. Similarly, you can execute these two also and note the corresponding output. Understand what is happening and why it is happening. Understand the associativity and the precedence of the operators in Haskell. Okay, now we'll understand what are basic logical operations in GHCI. Please understand that Haskell provides us with a what you can say data type called as Boolean, and capital F ALSE and capital T RUE, true and false. These are the Boolean values that a Boolean variable can have. So this is the domain for Boolean values, either a true or false. So if I type in F capital ALSE, okay, it will return false. Okay, it is interpreted as false. So whatever I'm writing here on the GHCI prompt, that is treated as a single line of code. So if I use now, if I want to use a and that is logical AND operation, true and FALSE, this will give me a false result, because doing a logical AND between true and false is always a false. And if I use both sides true, the resultant will be true. Okay, similarly, I can test the logical ORing operation, which is indicated like this. So true and true is true, and true and false is also true. Okay, if I reverse the order of the operands, that is, I make true false and false true in previously executed thing, it will still return true. Now, if I want to know the previously executed command, IT will tell me what is the output of previously executed command. The negation operation or Boolean negation operator is not. Okay, in C you find the tilde operator over there. Here we have it as not. So if I say not of false, it will return true. Not of true, it will return false. Right. Similarly, I can operate not on a collective expression like this. So true and false will is itself false and not of false is true. And that is exactly what we are getting as an answer. And if I use see false and sorry false and false, which is going to be false and not of false is true again. So that's how it evaluates. And instead of this, if I have an OR operation and this is true, is going to be false. So we have learned that and logical is represented like this, or logical is represented like this, not logical is represented like this. Okay, and now the comparison operators in Haskell are equals to for checking equality, not equal to, which is an interesting thing. So slash equal to, front slash equal to in Haskell is treated as not equal to operator. Okay, those who are acquainted with C, they are usually using not equal to like this. That we won't work in Haskell. So what you need to do is to check inequality, you need to test inequality, you need to do this. So if I have 2, it will return a false. It's a comparison is always a Boolean comparison, right? Either it is true or it is false. So other operators like less than, greater than, they are very much similar to C. Even greater than equal to, less than equal to, they are pretty much similar to C. In Haskell, a string is always enclosed in double quotes, and string is nothing but list of characters. Okay, so string is always treated in Haskell as list of characters, and this is how I can test equality. So this happened because of these quotes are not realized correctly. I copied it from word to over here, so it will happen always. So high equals to high. I'm checking whether these two strings match. If I use instead of high and this, it will come as false. Okay. Also note that I can't enclose string in single quote. If I try this, it will throw you an error. Okay. Fine. Now, as I executed a lot of things and it created a lot of garble over here, and I want to clear the screen. The command for clearing the screen is colon clear. Sorry, colon not clear. So any shell command or native command you want to execute, it should be colon not and clear. This will clear you the screen of the Haskell compiler. Okay, so this is exactly what you need to do in the write-up. So I'll just repeat the steps that you need to write in the write-up. You start with experiment number, sorry, not 2. 1 and 2 I have already discussed. So I'll be discussing only third experiment today. So you start with experiment number 3, aim, okay, then theory, okay, this much. And after theory, you will say that performance steps. We understood how to download and install Haskell compiler, part 1. We just need to say we have understood. So we have downloaded and installed. Part 2, you will be actually writing or making a table, rather not writing, making a table where first column of the table is this particular operation and second column in the table is the output. This is exactly what you do. Then for part 3 also you will do same thing. You will again create a table of 2 columns. Part 1 is this command and part 2 is its resultant value. Similar thing for part 4 as well. Once this is done, you will answer the questions in the post experimental exercise. And this exercise involves answering these 3 questions. So you need to explain features of Haskell programming language, which is already there in the theory part. You just need to repeat it. You just need to say you need to list basic data types in Haskell. We have studied about basic data types in Haskell. If you don't remember, We just need to copy this up into Google and just Google and find out what are basic data types in Haskell, and you will figure out a list of data types. Okay, a list of data types in Haskell, so you can read and find out yourself. So that's an exercise and you need to do it on your own. So nobody's going to help you doing that exercise. See types, predefined types and classes. Always it is good to get authentic help, and authentic help you will get from haskell.org site. Okay, this was the earlier site which I had opened, which has a lot of things, but may not be that much useful. Whereas if you go to Haskell site, it will tell you what are the standard Haskell types: Boolean, characters, list, tuples, unit data type, so on and so forth. So you just read through and you will be able to write the answer to the question. Okay, question answer should be not more than 1 or 2 pages. You need to differentiate between imperative and functional programming language. As far as your theory exam is concerned and practical oral examination is concerned, you should be able to be answering these questions in the post experimental exercise, which are there in the post experimental exercise. Finally, you need to write the conclusion as it is, which is given in the write up writing instruction. So this I'm going to keep it with the same folder, PCPF notes folder that I had shared, जिसमें पहले जो फाइल था उसमें सिर्फ 5 pages थे. Now that there are 12. So I'm just putting all the things inside the manual one by one as I'm typing it in. So today we have seen what we are supposed to do as part of experiment number 3 in the Haskell write-ups. I hope this is understandable, and you will be able to write the write-ups. Anyway, if you have any doubts in writing the write-up, you can ask those things by sending a personal message. Okay, so I'm stopping this recording now, stopping the session. Any problem in writing, you can just give me a personal message and I'll inform you what exactly is the correct way of writing.